All right. Check that. Mr. Cameron. Hello, everybody. Welcome to the FE Review Workshop, session number 2. Today, we're going to be looking at some engineering, economics, and ethics. We've got some problems lined up for today, and we're also going to go through the handbook to sort of get a better idea of how we should navigate it, the different different equations and tables that are in it for economics specifically, and how to use the search function. Now, on the actual exam, the search function is not going to be quite like, Adobe Acrobat, but it's going to be very similar. So let's go through this. So in our handbook, we can see, if you remember anything from economics, if you haven't taken it, that's cool too. There's a bunch of equations that you can use. So, but normally you won't be needing to use all of these because there's a much faster method, and it's called using the table, and it doesn't require you to do some calculations where you can make a mistake. We're going to get to the table later. But Cameron, everything's coming through all right? Sound is good?
Yeah.
Visuals are good? You see the tape? You see the book, the handbook?
Mm-hmm.
All right, cool. We'll get into the table later, which is an alternative method than using these equations, but regardless, all of these equations are here. There's a bunch of definitions for different variables here as well. If I let's say I wanted to find this page, right, and I was somewhere in the statics domain, if I were to search economics, or more particularly engineering, it searches through the whole PDF to find engineering economics. I could also search if I knew what the equation was, right? Present worth. We'll find that present worth, all the instances of present worth. Inflation as well. Inflation. There's a couple hits of the enter key and you can find what you're looking for. All right, moving on to the next page here, we have non-annual compounding equation. We have a description on break-even analysis, a description and equation on how to find the inflation-adjusted interest rate, straight line depreciation, and modified accelerated cost recovery. Oops. Book value, which incorporates the straight line of depreciation, taxation, capitalized costs, bonds, rate of return. All of this class has been coming back. Do you happen to take this class, Cameron? Did you take a 40? What is it? 40?
405 CE 405, I think.
Yeah.
Yeah. Took it last fall.
All right. I heard the thing make a noise. How do I find the? Okay. So the waiting room definitely doesn't work. That's great to know.
You're saying I'm not accepted in here, man?
No, you're accepted. I just had a waiting room enabled. It just doesn't seem to work though. Good to have you here.
Thank you. Thank
Valera.
you for hosting this. We appreciate all of your efforts.
Thank you. We're going through the engineering handbook right now for the FE, showing how to kind of navigate it using the search function, all the stuff that engineering, economics, and ethics has available.
Control F.
Control F, yes indeed.
Control F.
You're scheduled to take the exam pretty soon, aren't you?
Next Saturday, actually.
Wow, then.
Yeah, so let's cross our fingers that I actually fucking pass.
Get some reminders, huh? You feeling what do you call? Feeling good about it?
I pretty much did the where's my practice book?
Pretty
much did all the problems in here. I've been doing that for like 8 weeks.
Okay.
And then now this last week, I kind of just been reviewing everything.
That's a good idea.
But what I can gather from doing this shit, because when I was reading the reviews, they were saying that the test problems were going to be simpler than that. Like this one kind of over prepared you.
That's a good thing. That's what we're trying to do here.
Yeah. So from what I take from it is I would say a good 80% of the problems, if not higher, in that book, you can definitely figure out just going to the section in the handbook.
Right.
Because a lot of it's like plug and chug.
When we get into the topics like electricity, magnetism, and like dynamics, there might be some more involved equations. I know there's like AC circuits and rotary circuits, which I don't think, at least from our school, we never covered in class. So that's going to be something that you'd either have to like learn that concept on your own, or just, you know, be like, all right, I'm going to get an AC circuit problem wrong. So let's just make sure everything else is good to go and we can forego that. And you could pick your strategy.
Totally.
Anyways, getting back to the topic at hand.
Oh yeah, my bad.
We have our MACRS table, which will be used. We have a MACRS problem prepared here. We're going to go through that. We can see how that works. We have some economic decision trees, and then the most important, which are the interest rate tables from WA from 0.5 all the way to 18%. And that's basically the entirety of the handbook for economics. It's quite short, so everything that you'll need is likely going to be available here, which is mainly just equations. All right. If we wanted to look at, let's say, ethics and professional practice, this one is a lot of text. It's the entire code of conduct. So again, control F will be your friend here. If you want to find a particular, let's say the question asks about the model law, you could control F model law, and then you'd get a list of all these things. Typically though, with the ethics questions, from what I've seen, is a lot of them tend to be almost intuitive. You'd be able to sniff out the correct answer even without looking at this specifically. As you can see, there's quite a few sections just for model law. So it might take you a while if you look through all of these. But as we'll see in some of the example questions, it might not take you that long. Okay. With that said, we'll keep this handbook here. We'll refer back to it if we need to. But we are going to switch to some problems now. Some econ problems.
Econ.
And I can navigate this, annotate this. I don't have a tablet yet, so it's just going to be with a mouse. That's fine. All right. First problem. Permanent mineral rights on a parcel of land are purchased for an initial lump sum payment of $100,000. Profits from the mining activities are $12,000 each year, and these profits are expected to continue indefinitely. Most nearly, what is the interest rate earned on the initial investment? So we're being asked for an interest rate, right? Being asked for I. And we have to, let's pick out some words from this problem. We have initial cost. We have annual cost. No, that's profit. It's an annual gain. And we have, they are expected to continue indefinitely. So what we have is an infinite series of this. So we want to know the interest rate earned on the initial investment. All right. Can any of you tell me what equation I might need to solve this?
I am currently looking
To the handbook.
FB handbook.
There's typically whenever you see that it's an infinite series, you can use the capitalized cost formula. Okay, I'm gonna call it CT equals CI equal CI plus C cap. Total capitalized cost is equal to the initial capitalized cost plus, total cost equals the initial cost plus the capitalized cost, which is also equal to initial costs plus A over the interest rate I. Now, whenever you see an indefinite or infinite series, you need to think of this right here. Since, and this means our n, well, our n number of years is not defined. So there's no way we can use the typical factors from the interest table. I can show from the handbook, if I go and look up capitalized costs, we have right down here, we have one of the equations.
Yes.
All right, Control F, just thank you. All right. So we can see capitalized cost is going to be equal to the present worth, which is A over I, assumed perpetual period of time. So if we use that, go back here, it erased my drawings. Okay. Duly noted that if I do that, it'll erase everything I've done. Good to know. Okay. So if we take our initial 100K, 100,000, that's a great 100,000, I know. And add, what is it, 12,000 per year? Doesn't matter what the signs are here because it's going to be a percentage divided by I. This is going to be equal to 0. So we can move our 100,000 over, which is a cost. So I guess we should give it a negative, but you'll see and assume that won't matter. And we'll have 100K, let's call it 100K, times the interest rate is equal to 12K. So if you take 12K divided by 100K, we get what the interest rate should be. But if you do that, it's going to be around 0.12. We agree with that?
I agree.
Answer choice will be D here, 12%. So in solving this problem, you got to recognize that it's an indefinite series and it's asking for an interest rate. So if you remember the equation up here, A over I for an infinite series is how you can get the present worth. And since there was an initial cost attached to it, we can add, or, well, it's a cost, right? So we can subtract the initial cost. Which should be equal to 0. And just massage the equation a little bit to get the I. Or if we had the I and asked for A, we could find A that way too. Or
Sorry, sir, did you just say massage the equation?
I had a question about that too.
yes,
Follow up. Did you take a Mr. Alan Teagle Hernandez sometime during your collegiate career?
I have not taken Mr. Teagle.
Oh, so that just justifies how far his reach is into the
What?
minds of mechanical engineers.
Oh, does he say that too? That's pretty interesting.
Do all the time, man.
He does.
No one knows what he means.
The only thing I remember from Teagle is denominator. That's it. He could never say denominator. It was always denominator.
All I remember is he wears shirts that are way too tight for him.
Yep.
Remember, guys, this is recorded and will be going on YouTube. So they might hear you. Just saying. Anyways,
good-
oh, I
he's
could have
a very
done
good
this.
guy.
Hold on, let me test this really quick. What's the answer to this problem?
Submit.
Okay.
It
Yeah.
worked.
It worked. I end it, and I don't need to share results because, oh, can I share results? Is it sharing?
Can you share the results? Oh, there you go.
Okay, cool. Stop share results.
How many people voted in that?
2 people.
Okay.
All right, cool. So I'm going to do that for every problem. Get out of here, annotation. No, I didn't want to do that. Okay, whatever. All right, nice. Let's go to our next one then. All right, annotate back. Let's use this color. So we have $1,000 deposited into a savings account, pays about 6% annual interest. and there is no money withdrawn for 3 years. We want to know the account balance after 3 years. All right, so this is one where we can exhibit 2 different methods to solve. So we're gonna define all our variables first. We have $1,000 as our initial deposit. Call it the ID, not the ID array. And it's gonna pay 6%. It's gonna be I. And N is gonna be 3 years. The way I was taught to do these, if you have trouble visualizing what's going on, is to draw a cash flow diagram where we have down denoting a payment and up denoting either a profit or a return. So we're depositing, which we're losing this money, what's $1,000, going to be happening at the very beginning. So we're going to have 1,000 here. And then that we're going to have year 1, year 2, and year 3. 1 year, 2 year, 3 year. So we want to know the account balance at 3 years. So at this point here. So what we're going to be doing is moving this 1,000 into the future by 3 years. Sounds pretty cool, right? Yeah, I'm moving money to the future. Wow, time traveling. And to do that, there's 2 different ways we can do that. We can use an equation, which I could show you, but it would erase my drawings apparently. Or we can use a factor, which would also be difficult because it'll erase it. I need to get my own tables. That's right, that's what you guys are here for, right? So if we want to move this into the future, we have a present value. So this 1,000, we're going to rename it as P. And we want a value that's in the future. So we're going to be doing our factor being, we're going to have, we want F given P. I was taught you can treat the slash as a given. And if you always say it that way, F given P, we know that P is the value we have and F is what we're looking for. Same with like A given P. You get the annual value given a present. So with this, we have F given P. Our interest rate is 6%, and our year number amount is 3. So this is going to be a particular factor that we're going to multiply by 1,000 and get our money moved 3 years into the future with an interest rate of 6%. This is one method to do this. And if somebody in the call would care to tell me what the factor is.
Oh, there's
Control F.
Yep, those interest tables. I would rather not lose everything I have here. I guess I could look at it.
1.191.
1.191, you say?
Yep. Oh, Ryan, if you want to verify that, but that's what I found.
That's 1.19.
You get that from the equation.
Yeah, I can look at it. Let's see. 3 F given P. 1.191, I can agree with that as well. So this value, it's going to be, we're going to have 1,000 times 1.191 approximately. And what will that give us? Give us what? 1,191? Which I don't have the answer choices here because I answered this question accidentally already. But this would correspond to one of the answer choices. Okay. And you would select that. That's one way to do it. The other way would be actually to use the equations that we saw at the beginning of engineering economics. For F given P. I'll find it eventually. F given P is 1 plus I interest rate to the power of N. 1 plus I to the power of n. This will also get you the factor. So if we do, what is it, 0.06 plus 1 to the third, if you do that, you can see that it'll also give you 1.191. So there's two ways to do it. You can decide which one is better for you. Personally, I'd rather not have to remember this equation, even though it is pretty simple, but you're not always going to be doing the f given p. Sometimes it could be the other one and you could mix them up. So I think there's a higher chance of error using the equation than to use the table.
Yeah. If you
Cool.
find yourself trying to find p given a gradient, that equation is definitely not as simple.
Exactly. And it's a lot easier to mess with, and you might have to be on your calculator for a good minute or two. And typically in these, you only want to spend a maximum of about 3 minutes each problem. Obviously, some are going to be faster, some are going to be longer, but averaging about that, and it should be okay.
There's lots of problems and you can solve.
Exactly. Let's clear this and let's go to number 3. Let's go. That's it, right? Yes, it is. Okay. We have an oil company that's planning to install a new 80 millimeter pipeline to connect some storage tanks. Useless information when we're talking about economics. So we tend to not care about these meters and millimeters unless there is a cost attached to them. The connection will be needed for the foreseeable future. An annual interest rate of 8% is assumed. Let's get some writing in here. Please move bar. I don't want you right in the way. Annual interest rate. Annual is important. Annual interest rate. And an annual maintenance are be paid by their entireties by the end of the year. That means that we can assume that the annual costs are always paid at the end of the year, which is a nice assumption considering if we had a cash flow diagram and had some years. If the annual costs were not paid at the end of the year all the time, you could technically you could have an annual cost here and also have one here. Let's just say this is year 2's that was played at the end of year 2, and beginning of year 3, and this could be the beginning of year 3 to 4. Hold on. Let somebody join the Discord.
Yeah.
If you want to, Cameron, if you'd like to go and tell them that we're on the Zoom call. I need to. Oh, they're gone. Just kidding.
It's like they.
That was one of our officers.
I think that was Oscar. Hey, you know I attended your week of welcome, girls.
Wait, which one?
The one yesterday, Anthony.
Yeah, that one didn't happen though. Anyways,
welcome.
we didn't host it because we got literally nobody on Wednesday. 0 people except Margot.
Oh.
Wait, how did you? Anyways, it doesn't matter.
Yes, I have my.
Anyways, what I was saying here on the right, if we didn't assume that all of the annual costs happened at the end of the year, you could have one happen in the middle of the year, which could kind of throw things off in terms of when you're shifting things, because that means one would have to be shifted maybe more than a year, and it'd be half a year, and that's just weird. So that's an assumption that normally all these problems should have. Otherwise, it gets kind of weird how you explain it. So that's nice. We're going to have some information here, and we want to know what's the capitalized cost of running and maintaining this pipeline. So if you remember, we talked about the capitalized cost equation, which I wrote up down here for problem number 1. We had somebody join the call.
Oscar!
Yep.
What up, dudes?
What it do?
Nice to see you here. We're doing some engineering economics.
Dope. I'm like trying to get my schedule straight for the weekend and everything, but I figured I'd jump in here and listen in on everything you guys are doing.
Yeah, that's fine. No problem. Glad to have you. You can join the polls too. All right.
Appreciate it.
So Let me get my annotation back.
Why don't we just use that same equation that you used in the first problem?
Exactly. What does it look like?
You already have your, because you're solving for P in this instance, and then you already have your A, which is fucking, where is it? 1500? No, not 1500.
No, 1500's the
The initial cost.
is P, yeah. I believe.
You talking about A? No, yeah, this is P.
Yeah.
So you would do, wouldn't you just do 1500 plus 4? Plus 400?
Well, you cannot add them if they are different types. You'd have to convert one to the other if you wanted to add them. What is to say? Does not say it's an infinite series. So, but because it's asking for capitalized cost, we have to assume that it's going to be indefinite.
Mhm.
The equation that we did before was C initial plus A over I, right? Will get us the total capitalized costs. In this case, it's not 0. And we're going to call it CT. We have to pay attention here. This is not the only annual cost. We also have a pump operation, which we have to do some math to get. So we're going to call that A2. It's going to be 250 times 600, right?
Mm-hmm.
This one is going to be 400. So A total is actually going to be well, we're going to, let's keep signs consistent, minus 1900 cost, right?
1500.
And
You're
our
talking about 2.5 times 600 or
2.5 times 600 plus 400. And then we put a negative sign. I could just make it both negative here.
Wait. Isn't that redundant though?
Maybe.
The annual maintenance is, they're saying the same thing. They just put it, they just broke it down. The annual maintenance, they just broke it down in those two before. Because they give you hours per year. And if you do, right? What if you do 2 point?
I think that cost is more like the electrical cost maybe or something like that. That maintenance
Right.
seems like
They split it up because they want you to have they want you to incorporate both of them, but they're just giving it to you in a more realistic way that it'd be given. Like, this is how much it costs per hour to use this thing, and this is how many hours in the year that it operates. So you get one A from this two information, and then you get the other A.
I see.
From the other
what is the I under the A over I?
That is the interest rate. This is the capitalized cost equation. Sorry, this is also CT total. If you look in your handbook, you can find capitalized cost, which I believe is P equals A over I. I don't know if
I see.
that handbook has this particular equation, but from that P equals A over I, you can get this one, which is basically, this is for an infinite series. Because it's asking for capitalized cost, we assume infinite series. Sorry, C in. Let's go back to what is our C initial cost?
It's 1500.
Correct. All right, so we have our A total and our C initial. This is AT. And where is our interest rate? 8%?
Yes.
Over here. Negative 1500 again. As long as the signs are consistent, it does not matter what you use. Minus 1900 over 0.08. What does that give us? Just going to calculate it if you want. And
25,250.
You say 25,000?
25,250.
Okay. You guys want to do that? Come up with I'll give you guys a poll that you guys can take, and you can pick which answer do you think is correct. Should be. Dang it, where did the poll go? The poll die? Oh, it
I
did.
answered it.
Oh, you guys all answered it. Anyways, here's the results. And yes, that is the correct answer. The correct answer is 2400. Do all the steps here make sense logically?
So if so say we were doing like a fill in the blank question here, do you think personally that you would depreciate the value of the salvage life over the 12 years or no?
Yeah, in this particular example, we're not taking into account the salvage life. Typically, if you were asked for, let's say, the present or the future worth of this pipeline, whatever it is they're talking about, yeah, the connections. If you wanted to find what it was worth at a particular time, or an annual worth, what it's worth over this many years, yes, you'd have to take the salvage value into account. But since we're only talking about capitalized costs, the ticker being costs, we don't care about what it's making, what it's giving us in return.
I got you.
It's only talking about costs. So we can ignore the salvage value. The service life also doesn't matter at all, since we're asking about capitalized costs, which is assumed for, an infinite amount of time. It's just going to be in that instance. We don't care about what happens in 12 years once we have to do it again. That's the nature of capitalized costs.
Got it.
Hey, Chigueros.
Question?
In the do you have that same book though? We're working off the same book, no?
Yeah, should be.
How come they did it a different way?
Did they do it a different way?
They just because they didn't include that initial cost for some reason.
Did they get the same answer?
Well, in the book they got like 23,000 fucking something.
Yeah. 23,750.
Let me look. Try to see. Yeah, 23. What'd you say, Anthony?
23,750.
Yeah, because I don't know why they didn't include that initial cost, but it's odd.
Strange.
Yeah, that's like a $1,500 difference. So that's probably from the actual cost of it.
Mm-hmm.
Yeah, that's just taking into account the annual cost.
Interesting. I just solved it the way that I would have solved it.
Yeah, yours makes more sense. It's just I don't know why they didn't do that.
Present worth of an infinite cash flow. Well, it both got us to the same answer, but I mean, if that 2,700 was a little more stricter, it might not have been as interesting. I would still solve it the same way, but considering the equation I used wasn't in the handbook, maybe not.
Oh, okay. Wait, hold up. I googled the definition of capitalized cost. It says they are not expensed in the period they were incurred, but recognized in the period of time via depreciation or amortization. I'm not sure what amortization is. Depreciation or yeah, I guess that's pretty much it.
Mm-hmm.
It says it's added to the cost basis of a fixed asset. Huh. Okay.
Oh, that makes sense. Yeah, you lose value over every month. I took an accounting class for a semester for absolutely no reason, and they said that like the cost of it initially just gets every year put on there and split.
Well, if we want to stick to the equations that are in the handbook, I suppose we should forego the 1,500. I apologize for solving it that way. even though typically, I mean, I guess if this initial costs were much larger, it'd make a bigger difference in this particular problem. But
Yeah, no, yours definitely makes sense taking into account the 1500, but
regardless, though,
yeah,
for the purpose of the exam, this is a much. If you just know this, it's much easier just to take, okay, these times each other, plus this divided by that, and that's a thing, and you could solve that in like a minute or two.
Yeah, because I guess it kind of makes sense that you wouldn't take into account, like, just based on the equation, you wouldn't take into account the 1500, because we're already assuming that that's the present cost, you know. But I mean,
Right.
it never actually says that's the present cost. That's just the initial cost.
Mm-hmm.
Present cost could be.
It's likely for the same reason we don't take the 12 years into account.
Mm-hmm.
Probably why we should not incorporate the 1500 too.
Mm-hmm.
All right. Almost intuitive, this problem. All right, let's go on to our next one. Oops, not redo. We have something similar here. Wonder if it'll be the same kind of deal. We have a 200 millimeter diameter pipeline installed over a distance of 1,000 meters. Annual maintenance and pumping costs are considered to be paid in their entireties by the end of the years in which their costs are incurred. The pipe has the following costs and properties, as detailed here. What is the equivalent uniform annual cost, EUAC, of the pipe? So now we're being asked for the uniform annual cost. So immediately you should think, all right, it's asking for an annual cost. Let's get these annual deals taken care of. So we're gonna have to convert the bottom two into an annual cost, which is 2,000 times 2.75, and as well the annual maintenance, and add them together. So immediately we can go get our annual total, which is going to be these together. Let's see. $6,000. Yeah, 6,000. Now what else do we got? We got to, since we're being asked for the annual cost, we will assume that it's asking, take everything into account. We're not doing anything capitalized cost wise. So we need to change everything here into an annual cost. How do we turn a present worth value into an annual value? That's really large. How do we turn this 1350 into something spread out across 6 years? It's not quite dividing it by 6. There's something else we got to do. Anybody got something?
A over P factor.
Use a factor, right?
Yeah.
Factor would be what? A over P.
Mm-hmm.
A given P.
Yeah, yeah.
6%.
For 6 years.
6 years. Yep. That'll turn this 1350 into an annual amount. So this A, we're going to call it A1. I'll call this A2 down here.
Okay.
If we look at the tables, we got to look at 6%, right? 6%. 6 years. A given P. That factor is approximately, you guys get 0.203?
Yeah. 2034, 203.
203. So it's going to be 1350 times, okay, 0.203, which will get us about 274 and a half. Approximately. All right. One more thing we got to take into account, and now we got to do the salvage value. So very similarly, 120, A given what?
F.
F, right? Salvage value happens at the end of its life. It's a future value, 6%, 6. Anybody got the factor for that handy?
0.1434.
1434?
Yep.
Yep, I agree. I sometimes like to write things backwards, don't mind me. That's supposed to be a point. It's quite small, it's about $17 and
Mm-hmm.
0.2. But we now have everything that we need. Now we have to be careful which ones of these are costs, which of these are going to be negative on our cash flow diagram, which ones are going to be positive. Draw this really quick. I'll put the poll up for you guys to answer. Year one, we've turned everything into an annual worth, correct? Originally, we had 1350. It's 120, and then over the spread of this, I call it like this. We had 500. I'm actually 6,000 technically. I'm just going to call it 6,000 because that's the combined. So what we did is we spread out this 1350. We spread out this 120, and altogether, what is it going to be? Let's use 1350 is a cost minus 6,000, correct? Sorry, not 1350. What am I saying? 274.05 cost minus 6K plus 17.2. Does that make sense?
Yep.
Since the salvage value is a positive number.
Closest value that I got would be about 6,300. 6257 is what I got.
Let me see the poll. Oh, we only got 2. Did somebody leave? It's fine if they did, but
No,
I wouldn't be able to know. If Oscar left, that's cool.
Yeah, sorry. Yeah, I just didn't answer. I'm working on a couple other things too.
Don't worry about it. You're good. You guys both answered D. And yes, if you get around 6,256 as your result, which is the most closely resembles answer choice D. That's the correct answer.
So is this like a common theme for the FE exam that you're not just gonna get like an answer, but you kind of
Yeah, it's very rarely ever exactly what they put on the answer thing. I guess they don't engineer. They may not engineer the problems perfectly, which
I guess that
they'd
makes
have to
sense.
tweak the numbers very hard to be able to get an exact number.
Yeah.
So you have the chance of, potentially getting something that's really close to 2 different answers, and that's when you know that can't be right because
Yeah. Yeah. When it matches too close.
Hey, Chigueros,
Question.
for that last problem when we were doing the capitalized cost.
Right.
So I'm doing the diagnostic exams at the same time I'm doing this shit. And I encountered another problem for the capitalized cost. So we have to watch out for the wording because your method was correct. But in the wording of that first, problem number 3.
Back to it right here.
Problem number 3, it says, what is the
This one.
capitalized cost of running and maintaining? So that's why they did only the annual stuff.
Oh.
Because I'm doing like some other shit, whatever. And then I tried that same P over A, and I didn't get the right answer.
Okay, so you have to do the initial. If it's not asking for just this. You know what? That's a key thing that is easy to miss, is running and
Yeah.
maintaining. That's why you don't incorporate the I see.
Because this other problem says, what is the capitalized cost of this facility?
Hmm.
So you'd put everything
Then you put everything.
initial.
Mhm.
All right. All right.
Okay.
Okay. I guess it
Well,
makes sense.
yeah,
You
that's-
gotta pay
that's
attention.
tricky.
That's good to know. That is tricky. Hopefully they don't trick you that hard on the actual exam.
I'll let you know.
Watch on the exam. It's gonna be like, what's the capitalized cost of the initial cost or something? You know,
And it's just the
awful.
initial cost. Well, then that's kind of silly. At least you can answer it quickly.
Yeah.
All right, a lot of words here. We're going to use MACRS for this one. A construction company purchases 100 meters of 40 millimeter diameter steel cable with an initial cost of $4,500. Initial cost. Annual interest rate, 4%. Annual maintenance are considered to be all right. The annual maintenance cost of the cable is $200 a year over a service of 9 years. Use MACRS depreciation and assume a 7-year recovery period. What is the depreciation allowance for the cable in the first year of operation? A lot of stuff here. All right. We're going to be using the MACRS table. If you control F MACRS in the handbook, you should be able to find it.
Control F.
Just MACRS, all caps. I'm not sure if caps actually matter. And in that, you should find what the factor is going to be, because you can find the MACRS equation, which I believe is df, the depreciation, is equal to a factor times c, which is a cost, I believe.
Yep.
And this factor is going to be derived from that table. You guys can tell me what is the factor going to be. Do you know what information you need to use to get that factor?
What's our recovery period?
Recovery period is 7 years.
Oh,
7 years.
okay.
And
we're looking at the first year of that.
we're looking for the depreciation for the first year. So two
So
pieces of information.
Would that be okay? Because on that table, it's got like recovery period, recovery rate percent. Is that the number you're looking for?
Yeah.
Okay,
Yeah.
14.29.
Yeah, that's exactly it. So we know this factor is going to be 0.1429, right?
Yeah.
So now we have to find out what the C is. Well, turns out that cost is, now I don't know if this is because it's asking for just the first year, but the only cost we need to consider here is actually the initial cost of 4,500. So we're going to have 4,500 times 0.1429.
I mean, it makes sense
Mm-hmm.
if they're saying just first year.
So I don't know if you do like year 2 or year 3, if you have to incorporate like maybe 2 instances of the 200 per year. Could be definitely. But if you do this, you should get about 643, which is closely resembling this here.
Okay.
Yeah, I don't know, Ryan, if you've come across a problem that is similar to this, but makes you incorporate the annual costs. Let's say this was not the first year, but maybe the second year. We'd have to incorporate the 200 per year for year 1, and maybe spread this out, make this a present cost instead of an annual. Not sure.
So in that instance, would we do 4,500 plus P given A of that 200? But they don't.
That would be the intuitive way to do it. For that, I unfortunately am not sure if you would need to do that or not.
Okay.
That would be the intuitive way to think about it, though, because if we look, it's going to depreciate. Actually, now that I think about it a little more, we're looking on the depreciation of its current value. Its value is defined by what you pay for it in the beginning. So actually, it doesn't make sense to ever incorporate an annual maintenance cost, because that's maintenance. That has nothing to do with how much it's worth, right?
Oh, okay. Yeah.
Annual maintenance costs are considered to be paid.
Yeah, well, and then if you think about it even more, you're like, well, if it costs you like, this much, if you try to find like the total annual worth, you do incorporate the annual maintenance cost. So it could be either way, or I would need to see an example of it being used to facilitate it completely.
I think you're right. I think it's kind of like when you buy a car, and you drive it off the lot, it starts depreciating.
Mm-hmm.
I
Dude,
think
20% off the lot, dude.
Yeah, yeah, yeah. Like you wouldn't sit there and be like, oh, it's worth less now. I had to get the tires changed, or it's worth less now because I had to get.
Right. I guess you're right on that regard too. So I would say for depreciation, you shouldn't incorporate any annual maintenance or maintenance in general. It should be normally on the initial cost of what it was when you bought it, and it'll depreciate by this much in the first year. Okay, it's pretty good, pretty nice problem. Gotta love these interest tables. Okay, almost through with the econ. We can get to ethics pretty soon. Ethics is going to be nice and no math involved. It's just going to be what is the right thing to do kind of deal.
This is gonna be us discussing it for.
Yeah. You're going to be like, that's a terrible engineer. Look what they're considering him doing that. What is the world?
Are the authorities nearby?
Some of it you have to actually read up. I'm not gonna lie.
Okay.
Right, they do provide it with it, but I think it's best to not spend too much time on the ethics problems. If you need to read up on something, I would probably save that to do later, since it's just a lot of text.
Right.
Okay, we have a piece of equipment with an initial cost of this. During years 1 through 3, the rate of inflation is 5%, and the effective annual interest rate is 9%. The uninflated present worth during year 3 is what? Cool, guys, we got inflation. What should we do with inflation? Pose that question. What you thinking? So within inflation, we have to first find what is going to be our uninflated equivalent interest rate, I believe
During year
they
3.
call it. No, in general. Let me
Oh,
do
no,
a
I'm
quick.
reading the problem. My bad.
Let me quickly look up some inflation to find the equation. Okay, so it's the inflation adjusted interest rate per interest period. So it could be very possible that they give you this effective interest rate in terms of not annual, but like monthly or something, and you might have to change it to annual. But unfortunately, we don't have to do that here. We want the, this is going to be the effective, general inflation adjusted interest rate, which is D, which is going to be equal to, you're going to have your interest rate, the effective interest rate, plus the inflation rate, we call it F for inflation, plus the two multiplied to each other. So if you took this class, it should look pretty familiar. And that's really all there is to it to find that particular interest rate. Can anyone tell me what the adjusted interest rate for inflation is?
I got 14.45.
14.45.
Same. Yeah.
All right. Percent. I agree with that. That looks good. Now what? We want to get uninflated present worth. Well, we got the interest rate, so that's good. We want the present worth of something that was $5,000.
Oh.
So, and we want during year 3. So we're going to be going from all the way to year 3.
Mm-hmm.
This one is worded very strangely, in my opinion, because it's asking for the present worth of something that had an initial cost of $5,000 in year 3. I don't know about you, but that seems to me like a future kind of thing.
Mm-hmm.
But I assure you, that's not how you calculate it. It's weird. No, we want P. P given what? F, right?
Even F?
Yeah. Again, like I said, it's a little strange. P given F.
Oh,
of
that's weird.
14.54, and, well, actually, this is not going to work. We're not going to be able to do that because 14.45 is not exactly an easy one to find on the table.
Not easy.
So if we want P given F, we do 1. We can do this formula, 1 plus I to the negative n. That'll give us our factor, which is going to be around 0.6. Is that right? 0.1454 plus 1 to the 3, negative 3. 0.66.
Yeah.
So we take 5K times 0.066. And that'll give us our annual, sorry, our present, uninflated present worth. It's going to be about 3,327, which is very close to these two, but turns out to be that one. Yeah, when I did this one myself, I was kind of confused on whether it was really asking for a present value. I mean, it says present worth right here, but I don't know, it just feels weird to find the present worth of something in year 3 for something that initial cost was 5,000. It feels like we're moving it to the past. Because look, this 5K is all the way over here. Year 3 is all the way over here, right? Present worth of this in year 3. It's strange, but I don't know. Maybe the FE problems can be like this.
So that 5,000 is actually an F value.
Say that again.
So we're considering that 5,000, the initial cost 5,000 to be the future value, like the
Right.
F. That's so odd.
It is very strange,
But
isn't
it
it?
works.
And it's strange that it works. Yeah, the uninflated present worth during year 3. During year 3. Why would you ask for present worth in year 3? That doesn't make sense anyways.
Yeah, I mean, yeah, it doesn't.
I guess it's all relative. I mean, and if it's relative, then it really doesn't matter which one you do. It's just
Could we
depending
try
on
something
which
here?
direction you're moving it. What's up?
Could we try making that, because I read it, because if I'm taking the test, right, and I want to remember this shit, and I'm probably going to read it, you know, the future worth.
That's exactly how I read it too. And if you
So
did
if we
that,
make
this
other
n
ones-
would not be negative. It would be a positive n, and you'd get like an 800% interest rate, and it wouldn't make sense. Then you would be
What
thrown
the
for a
fuck?
loop.
That's so odd.
You get about 7,500
Yeah.
is your
Really?
final answer.
Wow,
Yeah.
that's so fucking weird.
And then you look like, wait, none of these are that. So,
Yeah, no, none of them are near that.
no, but if you think about it, the uninflated present worth should be lower, shouldn't it?
Mhm.
Because if it gets inflated, then the number would increase, but it would still be kind of worth, uninflated, it would be worth, the 3,300. But because of inflation, it's actually 5,000 worth 3,300, that kind of thing.
Huh. Okay. That's crazy.
I don't write the problems, guys. All right. Let's go on to, I think, our last economics problem. That's number 6. Whoops. Oh, we got 2 more. This was not so bad. I think we actually did one similar to this already. Computer with initial cost of 1,500. Annual maintenance cost of 500. Kept indefinitely. What do we remember about indefinitely?
Capitalized cost.
I is 4%. That looks terrible.
Oh, okay. Cool. So, of all expenditures. Okay, so this is kind of like what Ryan was talking about.
Give you guys another poll. Yeah. You guys can answer it if you wish. I'm going to go through it right now. You guys can work on it on your own if you would like. But what we're going to be looking at, C initial plus A over I. So take 500 divided by 0.04 plus 1500. And then honestly, it's kind of just a straightforward calculation at that point. But it is to counter the other example where this one is asking for all expenditures. So that's why this 1500 is incorporated. And all right, who guessed D?
Is that? I hope that wasn't me, dude.
I don't know. Was it?
I don't know. I pretty sure I put C, but I might have accidentally.
I can't see who put it, but maybe it'll show you here.
Well, I mean, only 2 of us voted, and I know I put C.
Hey,
Ryan.
What are you trying to say? What are you trying to say?
Anyway, this is one rare example where it actually is exactly the number that is posted, 1400. So that's cool. That was a nice short one. Finally. This is going to be some non-MACRS depreciation. 12 years, initial cost, salvage value, interest rate. What is the total depreciation of the computer for the first 5 years? Anybody remember the depreciation formula? DF, not the MACRS one.
Well, if you look up straight line method, it's cost minus SN. I'm not 100% sure what that variable is over the number of.
Yep, we have the cost minus the salvage
Right.
over years. Oh, already cursive's not so bad actually.
Savage.
So this will give us a depreciation that happens in 1 year. Since it's straight line, it's going to be, this is the depreciation for 1 year.
Okay.
What is that? 1950 divided by 12. Is that 180 something?
162.5.
All right. So this is the depreciation in 1 year.
Okay.
Depreciation for 1 year. And we want what? The total depreciation for the first 5 years. Okay. 5 years times 162.5, or not necessarily 5 years, but 5 times this depreciation value should get you
812.2, 812.5. So yeah,
Yep.
810. So we do nothing with the interest rate.
Interest rate is not needed.
All right.
Just like did we use the interest rate for the MACRS problem?
No, now that I think about it, no. I don't think so.
We did. We did use it, didn't we? No, we didn't. Did we?
No. We got the interest rate from the table.
Yeah, because we did the recovery.
Yeah, you're right. We got that percentage from the table. But for this one, we did not use the interest rate because we're doing straight line method, and there's no I guess there's no place for the interest rate to come in if you're doing the straight line method, because all you need literally is how much it depreciates per year and how many years it happened that it depreciated that much. It's not as accurate because typically it depreciates more in the beginning than it does in the end. That's why straight line method's not a super good evaluator of actual depreciation, but it's a method that can be used, and it's a problem here and could show up on the exam. I don't know why they want us to know things that are obsolete. Maybe it's just so we know why they're obsolete. Understandable. Where did my annotations go? Okay. You got that? Nice. Guess what time it is?
Adventure Time.
No, it's lunchtime. So we're gonna be wrapping up pretty soon. But we're going to be, if you guys can see this now, just taking a quick stab at some ethical problems in engineering. I actually don't know. We're all mechanical engineers here, right?
Mhm.
Is
Yeah.
anyone doing the other sections?
Yeah, I have Eric doing electrical, which is going to be Saturdays at 7 p.m. And Kevin's going to be doing chemical. He has
Wait,
on the schedule.
could you repeat the Eric's time?
7 p.m. Saturday. Yeah, he has something. He did a
That's
poll.
crazy.
He did a poll for the electrical students, and he got a unanimous poll for Saturday, 7 p.m.
How many people voted? Just fucking him?
I don't know.
Oh, shit.
I didn't check it, but apparently that's
Well,
what they want. So
I mean, if they have the same, no, I'm not going to say it. I don't want to say we're being recorded.
Well, you know what? It's not like we can go out anyway. Everything's closed.
True.
Yeah, I've noticed that a lot of the meetings that have been happening for like RMC and other things, like a lot of meetings are on weekends now, especially if you have anybody in the CS department. Somebody
Mhm.
just told me that their schedules were so bad, they have Saturday classes now.
Whoa.
yeah, I would
Whoa.
imagine that makes sense.
That's crazy.
There's
how
just
people
no
are
room.
voting.
I think I would just drop out if I had a Saturday class.
Right, dude, I'm not going to class 6 days a week.
No. I will
Well, I
wait till
mean,
this blows over and come back.
this
I'm
counts as a class almost, doesn't it?
Hey,
I
did
mean-
you get Connolly's email and the chancellor yesterday?
Yeah, for next
Yeah.
year.
Yeah.
Mhm.
Next semester?
Yeah, that was a heavy email from the chancellor, man.
Gee.
Yeah.
Okay.
I'm ready to get into an argument.
So tell me, everybody. I'm going to put the poll up starting now.
Oh, wait, hold on. Let me read this shit.
An environmental engineer with 5 years of experience reads a story in the daily paper about a proposal being presented to the city council to construct a new sewage treatment plant near protected wetlands. Based on the professional experience and the facts presented in the newspaper, the engineer suspects the plants would be extremely harmful to the local ecosystem. Which of the following would be an acceptable course of action? Oh, should the engineer contact agencies to get more data on the project before making an assumption? Should he write an article for the paper's editorial page urging the council not to pass the project? Or circulate a petition to the community condemning it, present the petition to the council, or should not do anything because he doesn't have enough experience in the industry to express a public opinion on the matter? All right, guys, let's see what you guys think it is. Wow, we have 1 vote so far. Now we have 2. If Oscar's not going to vote, that's fine.
No,
We're gonna
that's
end this.
Now that was me. I'm back now.
yeah.
Oh.
I'm reading. I'm coming up.
Okay,
with
cool. We'll wait for you. No worries.
I mean,
Let's say,
it's just like the lesser two evils on my part.
this one, it does not bode very well.
Damn, I answered wrong.
What? This one also does not bode very well.
No.
This one, it kind of seems like the engineer's kind of trying to force his opinion in this one.
Okay.
At least to me, this one doesn't seem very engineer-y. Like, basically what he would do is just write an article saying why it's not a good idea without really, like, you know, looking for more information on it. So the correct answer is A.
Okay.
Contact appropriate agencies to get more data before making a judgment.
See, I was thinking that. I was gonna put that, and I was thinking that, but I was like, he's already saying that he's got the professional experience to know that it's harmful, you know?
Here, allow me to
Yeah, I just think like 5 years really isn't that much experience. Like, think of yourself 5 years after graduating college. Like, I feel like I'm sitting here pretty dumb.
I would like to tell the person playing that theme song in the background to please stop. Thank you.
My bad. I have
Let me-
I'll turn it off.
Is it an alarm? That's funny.
No, that's just straight up the intro to The Office.
Okay. I mean, yeah, I guess it makes sense now. 5
Here,
years.
let me read the exact solution that it says. It's the engineer certainly has more experience and knowledge in the field than the general public or even the council members who will have the vote on the issue. Therefore, the engineer is qualified to express his opinion if he wishes to do so. Before the engineer takes any public position, however, the engineer is obligated to make sure that all the available information has been collected. That's the official solution or answer.
Okay. Yeah, I guess when you put it that way, it makes more sense.
Cool. Hey.
Yeah, I think
Nice.
it's more of like a first step kind of thing.
Right. Yeah, like they were saying, the engineer has more experience than the council. So do you think the council would really be able to? They probably would believe the engineer, believe it or not. But I guess it's don't jump to conclusions that it's going to be bad, is what it's saying.
Yeah.
What if the engineer graduated from Cal State Long Beach?
Then their opinion should be much greater, right?
Yeah, exactly.
They have plenty of experience because, we do a lot of stuff with power plants over here.
See, this is a weird one too, because it's like, so the city council voted on it, right?
Mm-hmm.
Okay. I mean, I don't know.
There's a paper with a proposal being presented to the council. Yeah.
You're putting an awful lot of trust in government officials, in my opinion.
Yeah.
They're going to sit there and be like, well, let's not cut any corners. We're going to do everything 100% by the book. This is safe.
Yeah. Like I think Oscar said, it's kind of like the first step that you would do.
Yeah.
Acceptable course of action.
That's saying like they presented it, but I think you would assume it hasn't come to a vote yet, so you have some time before, because the council needs to learn all that stuff.
Right. First, you get the information, then you circulate the petition condemning the project.
Yeah, then you burn it to the ground.
Then you burn.
Yep.
Then you go to arson. Then you talk to Christine.
All right, let's try this next one. Here we go. It's got the poll whenever you're ready to. I'll read the problem. An engineer is consulting for a construction company that has been receiving bad publicity in the local papers about its waste handling practices. Knowing this criticism is based on public misinterpretations of the papers and the paper's thirst for controversial stories, the engineer would like to write an article to be printed in the paper's editorial page. What statement misdescribes their ethical obligations? A. The engineer's relationship with the company makes it unethical for him to take any public action on its behalf. Remember, this engineer is consulting for this construction company. It's consulting for them.
Consulting.
The engineer should request local representative of the engineering registration board to review the data and write the article in order that his impartial point of view is presented. As long as the article is objective and truthful and presents relevant information, including the professional credentials, ethical obligation is satisfied, or the article must be objective and truthful, present all relevant information, including the engineer's professional credentials, and disclose all details of their affiliation with the company. All right. Let's give you guys a couple more seconds on that. All right, we got everybody answered. Nice. Let's look at the results. Wow, would you believe it?
Oh.
All right, so let's go through this one. Obviously, C, none of y'all picked C, which it was a good idea. C is not right. C talks about, as long as it's truthful and present information, it's ethical. But it may sound like it could be correct, and it does. Most of these sound like they could be correct. It doesn't capture everything, right? Let's look at A as well. The engineer shouldn't make any public action because of the relationship with the company. It's unethical. Well, if you're working for the company, and I believe you have, it should be ethically okay for you to, clear misunderstandings people have about it. So A also is out.
Yeah.
C was out as well. So now we have B and D. Which one is it? B is the engineer should request a local representative of the registration board to review the data and write the article in order for that impartial point to be presented. That one seems logical. The article must be objective. This is the engineer writing the article, I think. the article that the engineer writes must be objective and truthful, present all relevant info, and including their professional credentials, and disclose all details of their affiliation. So this one, basically, the engineer would talk about his affiliation, give his professional credentials, disclose all the details, and be objective and truthful, versus request a representative of the board to review. So this one, the engineer is leaving it to the registration board to review the data that people are talking about and write the article in order. I believe that should not be in. I don't know, that sentence is worded a little strangely, but write the article saying that an impartial point of the view will be presented. So this one, the engineer takes matters into his own hands. This one, he asked the registration board to do it. I'm going to say right now, I think this one makes the most sense because the engineer is using his own knowledge and relationship with the company to clear up their misunderstandings, using his professional credentials as his what's it called? His backup, his kind of background, his face. Whereas this one, he's just going to leave it to the engineering registration board. What the heck is the engineering registration board going to do?
Gonna investigate it.
They don't know anything about the company.
Dude,
It's the people that work there that know about it, right?
I figured that he'd go to the registration board, and then they would probably send someone, to kind of inspect, look around, kind of like an OSHA thing, but not really, just have someone like see what they do for waste distribution. Is that it? Yeah, waste handling.
Right. Let me read the solution. It is ethical for the engineer to issue a public statement concerning the company that he works for, provided he makes that relationship clear and provides the statement to be truthful and objective.
So I kind of felt when I was answering it, like you don't, as an engineer, like you don't really have the authority to say that kind of stuff about your company on the public record without their approval or without them being the ones to release the statement.
Well, if you think about it, would it be difficult to get that approval if the common perception of the company was negative and that was false? Don't you think that company would want that engineer to go and clear up the misunderstandings using his license as an engineer, as his background, saying, hey, that stuff's not true, this is actually what we do, and they make it truthful and objective sense. Instead of having the engineering registration board be like, hey, everybody, they don't do that, they do this. Why would people believe? I guess maybe they might believe a registration board, but
yeah, I suppose if you're an engineer and you're already being hired to consult, I guess you're a bit higher than a regular engineer would be.
I'm just gonna say I answered this one. I did get this one wrong. I think I put B, I believe, as well, and it was wrong. I'm like, what? That's wrong. It seems like it could be right, but
yeah, because I don't know. I'm sitting here thinking it from like personal, like if I was just like of the population and someone came out and was like, no, like here are my credentials. This is why for me it'd feel like they're trying too hard.
Yeah.
Well, it's like you're passing the buck.
Again, this is all based on the engineering code of ethics, which obviously for a question like this, you're not going to read through the entire thing,
the entire code,
just to figure out what the answer to this is. No, I don't think that's realistic anyway, unless it tells you where it's quoted or something. So this is just going to be one of, if you get a problem like this, where you might just have to flip a coin to get it. At least you can narrow it down to 2. Guessing is your best point of your best way to solve it after that.
Well, I chose D because I was thinking from the owner's perspective. Like, if I'm hiring this dude, and he's got professional expertise and he's got credentials. If someone's like saying something bad about my company or whatever, or for my company, then if I'm paying him, like, he better use his credentials and say, hey, look, this thing is not right. But the ethical part of it would obviously be to, like, when he writes it, I am consulting for this company. That way there's no like muddy waters.
Right, exactly. He's disclosing, this is what I do for this company. And I know this because I work here. Because all you guys are saying is that's public
Right.
But bad publicity because of the local papers have misconstrued something.
Mm.
I think if you go to the engineering registration board, it literally is the same. It's on the same level as the publicity papers, right? It's someone that's not the company that's making a claim on what the company does. I don't know. That's the way I think about it. But looking back at it, I can see now why D would be the best answer. Oh boy, getting ethical, huh?
Yep.
I don't have as many of these as I have the other one because they kind of repetitive fast. But here's another one.
Okay, just want to let you know I got a meeting coming up, so I'm gonna log off here. Okay.
That's cool. See you later. Thanks for joining us.
Later, Anthony.
See ya. See you next week.
Mm-hmm.
See you guys.
Ryan, you still here?
Yeah. I can stay on if you need me to.
You're good to go. I'm just gonna. There's just literally this question is probably gonna be the last one.
Let's do it.
All right. If one is aware that a registered engineer willfully violates a state's rule of professional conduct, what should one do? Should you do nothing? Should you do nothing? You're obligated to do something, so that's not the right answer. Immediately. So we report it to the registration board, we report it to the employer, or we report it to the parties it affects. All right, guys, poll ready. Let's go. I gave you guys a cool hint that it's not do nothing. Unless you're doing economics, and then there is a do nothing alternative always. All right, got our polls in. 20 seconds.
Good.
Here are the results. All right, what's the correct answer? Let's see. Do we report it to the board, report it to the employer, or report it to the parties it affects? I don't think this one makes much sense because I'm not sure if just telling the people it affected, hey, this engineer like kind of gave you some bad designs. I don't think that'll solve anything because I don't think the parties that it affects can have any real effect and have like other than giving them a bad review, they can't like force the engineer to take responsibility. But the employer could fire the engineer. But then again, I don't think the employer can sort of take their license away, right? So the best answer here is actually B, that you report it to the engineering registration board, and they would be able to give the appropriate repercussions to the engineer that's violated the code of conduct. You certainly could tell the employer or the parties that it affects, but that won't get to the root of the problem the fastest. Because then you might have to go through the parties it affects, which eventually gets to the employer, which eventually gets to the registration board, and that jazz. But B is the most correct answer. And if we want to know what the solution says exactly, it's very short. The violation should be reported to the organization. To the organization. Is this the right one? It's just number 3 or 4. It's 3. Huh, that's weird. The violation should be reported to the organization that has promulgated the rule. Okay, which is the registration board. I suppose that makes sense. Yeah. I don't think I've heard the word promulgated before.
Yeah, that's a big one.
That's a big one.
Quickly look that up. To promote or make widely known. Yeah, to the ones that made the rule, the code of conduct is the one you should tell if somebody breaks it. Yeah.
It sounds like it's just promote and propagate put together.
Propagate.
Yeah, I guess you're right. I guess English works like that, huh?
What is for lunch today, Mr. Chigueros?
That's a good question. I really like Irish breakfast tea.
You say what now?
I really like Irish breakfast tea.
Is that coffee with whiskey in it? That's
No, it's nothing that extreme. It's tea that you eat. That's
it's like
Irish.
English breakfast, right?
It's like English breakfast, but it's Irish, and it's much thicker. It's very full. It's full bodied and
Full body.
doesn't have as much of an aroma as English breakfast.
Is
or
it a
Earl Grey,
herbal tea
but
or is it
it's black.
Oh, it's just black tea. Okay,
I'm gonna
It's-
try
it's
that. That
black.
sounds good.
It is. It is really good. I
I like that.
recommend it.
I like that.
My personal
What-
favorite is Earl Grey, but
What is for lunch today, Oscar?
all right. Just let me end this real quick. Thank you everybody for joining. We're going to be ending here on our workshop. Thank you, Ryan. Mr. Cameron has left already. Oscar, thank you for jumping in as well. We hope to see you next time. If you have any questions, leave them in the comments below. Make sure to hit that subscribe button if you want more FE content.
Smash
And
that like button.
Smash.
that as well. Smack it all day. It will never get tired. All right.
Later, guys.
Take care.